Good afternoon to all. Today we are going to learn to construct the molecular orbital theory with the help of group theory. So we are taking the example of AB3 type of molecule. So always remember, whenever you are trying to construct the molecular orbital theory, you have to divide the molecule in terms of central atom and peripheral atom. Since we are taking the example of AB3 over here, right? So what we will do, first we will figure it out what is central atom and then what is peripheral atom. So in case of AB3, the central atom is A. Central atom is A and the peripheral atom is B. So these peripheral atom are called as fragment orbital and central atom as usual. So if we take an example of BS3, S3 will be act as fragment orbital and boron will act as central atom. Right? The next job is we have to find out the SALC equations for fragment orbitals, and in that way we have to derive first to apply for H3 and then we have to set up the geometry. So the approach will be first to generate reducible representation, then use the reduction formula and then use the projection formula. We will take it one by one. Now, see, this is the BS3 molecule. Okay, so first we will find out what is the point group. So in this case the point group is D3H. In case of group theory, you have to define the axis first. So here I have shown it that boron y-axis, x and z is coming perpendicular. Okay, so what are the symmetry elements present here? One is C2. From where it is going to pass through? It is going to be passed through from this bond, right? So one C2, second C2 and third C2. Okay, now what else is present? So if we will try to rotate the molecule from the boron, this hydrogen will move to here, this one is going to be here and this one is going to be here. So we are trying to rotate the molecule with the angle of 120. So the axis of rotation will be C3. So two axes of rotation, C2 and C3 is present. I have shown it over here. You see that? This is the C2, right? Along the BH bond and third one. And B is passing through the boron and trying to rotate the molecule. What are the mirror plane which are present? Of course, if C2 is present, then in most of the cases sigma B will also be present. So here, this is the sigma B. We are passing the plane, right? This one. Okay? Sigma H is also being present. That contains the whole molecule. Okay? And the next symmetry element is S3. That is improper axis of rotation. In the classification of point group, I have already informed that first you have to see to it that whether the molecule is linear or non-linear, and if it is non-linear, then we will see that C2 is perpendicular to the Cn or not. If it is so, then the possibility of the point group will be DNH, DND and DN, right? With that way also we can help it out that what is the point group of this molecule, but I have shown you that what are the symmetry elements which have been present. I am going to use that. Now, in the first slide, I have informed you that to construct the SALC, we have to find out the fragment orbital and the SALC for the fragment orbital. So these are the three hydrogen I am taking it, right? I am taking the example of BS3. Now, during the symmetry operation, if any changes are going to be happen, then we will write it as +1, and if phase are going to be changed, then we will write it -1. Now let us move ahead. So this is a point group. Okay, this is a point group D3H. These are the symmetry elements which are present. Now we will take it one by one. So during the symmetry operation E, what we are going to do? We are going to rotate the molecule with the angle of 360, and all the three atoms, the moment I said atom means these fragment orbital, they are not going to change, right? If there will be no change, then I said the contribution per atom will be +1. So in that case, total hydrogen 3. So it will contribute 3. Now, C3. In case of C3, what we are going to do? We are going to rotate the molecule through boron. So all the hydrogen are going to be changed. If you will see here, this dark, without color and shaded. So all these three are going to change their positions. So in short, there is a change. That's why the contribution will be 0. Now C2. In case of C2, you are passing the axis through BH. Right? So that BH, H is not going to be changed. Remaining 2 H are going to change the positions. That's why here the remain unchanged will be 1. In case of sigma H, it is containing all the molecule, right? So all the hydrogens are going to be remain unchanged. That's why it is 3. Improper axis of rotation. It is a combination of C3 as well as sigma H. So already in case of C3 the contribution was 0. So without solving I can write it, the contribution will be 0. 0 means all the 3 are going to be changed their positions. Sigma V. Sigma V is the plane which has been passed through one BH bond, right? So again, the only that hydrogen is going to be remain same, right? So this is the representation of the atoms which are going to be remain unchanged. Now the next job is we will find out the reducible representation. So this is the formula, right? And IR is equal to 1 upon H summation of K IR multiplied by chi R, right? Now see, what is H? H is the order of group. So in case of D3H, the total number of the symmetry element is 12. So we will write it as here 12, right? K. K is basically the number of symmetry element of this particular. For example, in case of E, what is the value? 1. In case of C3, what will be the value? 2. In case of C2, what will be the value? 3, and so on. So let us take one by one. This is the A1 prime. These are the characters, right? You have already solved it for the fragment orbital and come to the point that these 3 atoms are going to be remain unchanged during this symmetry element. Let us put it in the formula. So what will write it? 1 upon H, then 1 upon 12, 1 K value, for E it is 1, then A1 prime, that is 1. This information has been taken directly from character table, which I have not shown it over here. So this information I have taken directly. Okay? So now put it on the formula. So 1 upon H, 1 multiplied by 1 multiplied by 3 plus, now see, 2 multiplied by 1 multiplied by 0 plus 3 multiplied by 1 multiplied by 1 plus 1 1 3 plus 2 1 0 and plus 3 1 1. So if you will solve it, you will come to know that A1 prime is going to be contributing the 1 terms. Okay? Now next. So this is the character table. Now see. In earlier slide I have shown it here. This A1 prime I have taken out here, right? So we have to apply on every Mulliken symbol, right? So you have to apply it on A1 prime, then A2 prime, E1 prime, and so on, right? Here I have shown it for A1 double prime, and the contribution is showing 0. Okay? Let us move ahead. Now, if you will solve whole the character table with the help of reduction formula, you will come across that only these two are going to be contributing. This is A1 prime plus E prime. Now in group theory, A1 means a single orbital, right? And E prime means it is having a double degeneracy, right? A1 prime correspond one non-degenerate orbital, but E prime correspond that doubly degenerate. Okay? Now, here A1 prime is already been present in case of character table, and the value will be 1 because it is highly symmetrical. Now, you already solved this. So, if I want, I have to verify whether our answer is right or wrong. What we'll do? We have options. We can subtract from this to this. So, this information should come. For example, if you will solve it, the tau minus A1 prime will give you the information of E prime, right? And A1 means highly symmetrical characters. So here all the value will be remain 1, right? 3, 1, 2, 1, 0, 1, 3, and so on, right? Now you see the same value you are going to get it here, E1 prime. So it corresponds that from the reduction formula you got the correct answer. Okay? Now, the second approach was to apply projection formula. First reduction formula, then projection formula, and later on we will fuse the boron and hydrogen, right? Now, earlier I have told you that the approach should be first to apply reduction formula, then projection formula, and then we will try to fuse the same symmetry of orbital. So in first information we have gathered that A1 prime and E prime are going to be contributed. Now let us find out what will be the contributions. So in that case what we are going to do, we are going to apply the projection formula. Now I have shown it here. S1, S2, S3, right? See, axis is same. In group theory, axis play a significant role. If you will go through with a different book, they may have the different approach. But final answer will be same. The only reason is axis. They have opted the different axis. This is a freedom. Now see, this is the S1. Now we will target only S1 first. S1 symmetry operation E, you are trying to rotate with 360, you are going to get it same. Agree? Next job. Now, if you will try to rotate through C3, right? What will happen? C3 is, S1 is going to be occupied on this position, right? And what exactly it was? It is S2. Are you getting my point? So, it will be S2. S1 will be S2 once you will operate through C3. Right? This is the clockwise rotations. Another C3, anti-clockwise direction. So if you will rotate with 120 in this anti-clockwise directions, now S1 will be S3. Right? Okay. Now let us go ahead and we will come to know that why we are trying to do this. Okay. These are the symmetry elements which I have already discussed. That what are what are those? Now next, projection. So in case of projection and reduction formula, the basic difference is the K. In reduction formula, what we are trying to do, if 2C3 is present, then we will write the value of K as a 2. But in projection formula, you have to expand it. So if we write here C31, C32, 3 type of C2, then C2, C2 prime, C2 double prime, and so on. Right? Overall, the basic character is not going to be changed. If you will see, it is E, 2C3, 3C2, 2S3, and 3 sigma. And this sigma means sigma V. Okay? Now, what I am going to do, we are only focusing on S1 now. Earlier, we have tried to rotate all 3 hydrogen. That is reduction formula. Now we will focus only on one, and I have already cleared that S1. Okay? Now see, if you are going to operate through E, whether the S1 is going to be changed. In the previous slide I have shown, nothing is going to be changed, so we will write it as S1. Okay? Now, if you will rotate C3 clockwise, so S1 has turned up to S2. Now see that. I will show you. Wait. Now see, C31 clockwise direction, S1 turns to S2, anti-clockwise it is going to S3. Okay, this we are going to use it. Now see, C31 clockwise, so S1 will turn to S2, C2 C3 anti-clockwise, right? So now it will be S2, S3, C2 remains same, then 2 will come on 3 and 3n is going to be 2, right? So S3, S2 and so on. So what we are trying to do, now in this case we are going to focus only on S1. What changes are going to be happen with respect to the S1 after performing the symmetry element? In the first slide what we have done it, we are seeing that whether all the 3 hydrogen are, the fragment atom are going to be changed or not, that is reduction. Next is called as projection, and in that case we will focus only on one. And the another difference is that here we are expanding. Okay, so if you will see sigma H, it is going to contain all the hydrogen. So that's why if you will see that only boron is going to be remain unchanged. That's why I have mentioned it over S1, right? And so on. Now from the reduction formula we have come across that the contribution will be from A1 prime and E prime, right? A1 I have taken from the character table directly. In group theory, A1 means highly symmetrical, most of the character will be +1. Okay? Now, put it 1 multiplied by S1, so you got it S1, S2 and so on. So you just solve it. Okay? Overall, if you will put it in the projection formula, you will come to know that it is 1 upon 12, so finally it will come 1 upon 3, S1 plus S2 plus S3. Right? One information can be gathered over here is all the S1, S2 and S3 are in the same phase. So if you want to draw the depiction, then all the 3 should be in the same phase. Okay? If you want, you can put it over the shaded also, it is of your choice. But all 3 should be shaded, right? I have preferred unshaded one. It corresponds that from this SALC equation, we come across that all the hydrogen contributions will be in the same phase. Okay? Now, let us move ahead. The next job is to find out the equation for E prime. As I already told you, E means doubly degenerate. Okay? Now, remember that. Again, I have taken this from character table. I have written it as 2 minus 1 minus 1. So basically, this information I have taken from character table. Okay? So in practice, what changes are going to be happening, right? Again, S1, S2, S3, right? After multiplying with this, we came to know that this is going to be H. Now put it in the projection formula and so on. If you will solve, you will come to know that the equation will be 1 upon 6 2 psi S1 minus psi S2 minus psi S3. To make it simple, you can also write it as 2 S1 minus S2 minus S3. Okay? Now, if I will ask, draw the graphical representation of this particular equations. Now remember, these S2 and S3 are having minus. Means still they are in the same phase but differ from the S1, right? So if you will try to draw, then in that case remember these 2 are having same phase and the first one will be different. So this is S1, this is S2 and this one is S3. Is it clear? Okay. See, till now what we have done it, again we will repeat it. First we have applied reduction formula. From the reduction formula that we came across that the contributions from the fragment orbital will become through A prime, A1 prime and E prime. The next job is what will be the equations for A1 prime and E prime, and that information can be gathered with projection formula. So what we have doing projection formula. In A1 prime, we came across that the equation will be S1 plus S2 plus S3. In E prime, we came to know that it is 2s1 minus s2 minus s3. So in short, two of the hydrogen orbitals are having the same function, however the first one will be different. Okay, but the basic thing is that even prime should have doubly degenerate orbital. Till now we have found out only one equation, right? The same thing I have mentioned here. See, degenerate fragment orbital and the orbital should be, number of orbitals should be 2, right? And you have found out the equation for only one. So now the question is, what is the next, right? That's why this is smiley, I have put it over here to think about it, right? Now, this is about the group theory. We will come back that how we are going to calculate the second equations, but think about it. H3, if I will ask S3 only, then H3 can be made up of H2 plus H, right? Now, just think about it, it's a depiction. H2, it can be formed if two orbitals are going to be mixed up, two orbitals are going to be resulted. That is the basic of MOT. So one will be bonding, another will be anti-bonding. Bonding means same phase, anti-bonding means opposite phase. And in both of these two, another H is going to be combined. Are you getting my point? What I am trying to say that if you will try to fix up the MOT of H2, what is going you are going to get it? Simple bonding and anti-bonding. Right? Now, if I will write it as this is S1 plus S2, so what it will be? It will be S1 minus S2. If this particular information is going to mix up with this, what you are going to get it? H3 MOT. And if this H3 is going to be mixed up with B, then you are going to get it BH3 MOT. Right? This is a B3 molecule. Okay. Check. H2, bonding, anti-bonding, I mentioned, and S3 can be formed by the H2 combination with single H. Right? So now think about the possibility. One possibility is that this hydrogen will have the same function as this. Right? Another possibility is that this function is having opposite of this or same of this. The moment it is having opposite of this and same of this, then in that case two orbitals are going to be formed. So total number of the orbitals should be 3, which are going to be contributed. And equations till now you have obtained only 2. So one is basically missing. We'll figure it out. How do we are going to calculate? Okay, I hope it might be clear to you. Again, I will repeat whole thing. What we are trying to do? We are trying to do basically to find out the SALC equations for fragment orbital, right? Fragment orbital was H3 first, and then after getting the information of the SALC equation of fragment orbital, we will try to mix up with boron. So till now we came across that A1 prime equation is S1 plus S2 plus S3, E prime equation is 2S1 minus S2 minus S3. Now it is E prime means doubly degenerate, so 2 orbital means 2 equations. This is the one information we have been gathered with the help of group theory. Even if you will not talk about the group theory, just think about it. Basics. What is the basic? Whatever the number of orbitals are going to be mixed up, the same number of orbitals are going to be formed. Now H3 can also be split up in the two form. What are those? H2 plus H. Agreed? Now H2 means H and H. If these two are going to be mixed up, how many orbitals are going to be on? 2. One is bonding, another is anti-bonding. This is the simplest one, right? If it is bonding, in case of 2, S1 plus S2. If it is anti-bonding, it means S1 minus S2. Now, the point which need to be strike out is this H2 is going to be fixed up with another hydrogen, right? This is. Now, it can either align with the phase of bonding or it cannot have alignment. Alignment is same phase or different phase. So overall the possibility will be 3. So till now you have found out only A1 for one and E1 for another, right? Now the next is, now see, this was I was trying to say. This is the one possibility, right? This is the bonding. This is the anti-bonding. Okay? Of hydrogen. Now this is the one single atomic orbital of H which is going to be fused. So in what way? I have drawn it here. This is H2 and this is H. After getting to be mixed, it should be trigonal. These are the two going to be fused with one. What are the probability? Either it should have the same function that is already been there, and you have also gathered the information. It is S1 plus S2 plus S3. The next job is either it will be the remain same for this, right? So in this case, again, two possibilities are there. And what are those? These two. Now, see carefully. If you will see, I can write it directly, the equations from this depiction, and that is 2S1 minus S2 minus S3. How? Because see, we know that these two are in the same phase and this one from the different phase, right? So S1 is having different phase and S2, S3 are same. Another, if you will put it as S2, S3, so I can also write it as S2 minus S3, right? Now, but we will find out through equations. Now, move ahead. In what way we can solve with the second equations? See, to find out the second equations of E1 prime, always remember both the equations should be orthogonal. So orthogonal rule is function of I, function of j, d tau should be 0. In a simple language, if you are going to operate both the equations, it should become to the 0. Okay? From the depictions I told you that the possibility is S2 minus S3. Let us see that whether it was right or wrong. So what I will do, I am having one equations that I have solved it. Second, I have got it from depictions, right? From the probability. Now let us operate these two. And if they are going to be 0, okay? So it means that this is the correct equation. Now let us do that. Now let us operate it. Okay? Now see. 2 psi S1, then S2 d tau minus 2 psi S1 psi S3 d tau. Okay? Next 2 minus S2 S2, then S2 S3 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 and so on, right? If two are going to be operate on the same, then the answer will be 1, right? So this S2 S2 will be 1 and here S3 S3 will be 1. Okay? Remain are going to be S. Remaining are going to be S. S1 S2 S1 S2. Now we will do it. So the equation turned up is 2S minus 2S minus 1 plus S minus S, and if you solve it is 0. So what we can conclude it is as the second equation is also right, which we have to find out from the probability. Okay, since here the number of atoms which are going to be mixed are lesser, that's why the probability has been worked out. But still, if you will move ahead for AB4, AB5, AB6, this will be quite difficult. But this probability really helpful for the depictions as well. Now, so we are having three equations now. One, this one, same phase. Second, two are same phase, one is different. Another nodal, and this one where it is S2 minus S3. Okay? So what we got it? We got all the three equations of fragment orbital. Now the next job is to construct the MOT. We have to find out we have to mix up with center atom. Okay? Now, before making the molecular orbital of BS3, this is the checklist which we need to see before moving ahead. Okay? Now, see what I have written here. First, I have summarized all the things. What I have done it. First, I have determined the molecular shape. In this case, it was trigonal planar. I have taken the example of BS3. Okay? And identify the point group. The same thing I have done it. So the point group was D3H, right? Okay. Next job, what we have done it. We have to define the axial system. I already told you in group theory, whenever you are trying to make any symmetry operations, always focus on axis. Okay? Then identify the chemical fragment. Next, determine the energy level and symmetry level of the fragment orbital. Combine both. Determine the number of electrons in each fragment. Identify the MO mixing. Annotate your diagram and analyze the MO diagram. So, first shape, then point group, then axis, then fragment, then reduction formula, then projection formula, then equation and the equation of the same energy, and then mix up with the center atom. This is the checklist which need to be there before jumping to BS3. Now, okay, this is again cross checking. We can move. Now, so here, if you will see in the left hand side, I have put it the fragment orbital, and in the right hand side, I have put it central atom. So the central atom is boron, peripheral is S3. These are the depictions. Now see, if this and this, I mean to say this one as well as this one are going to be mixed up, then you are going to BS3. Okay? For today, we will keep it till here. For the rest, we will meet up later. Thank you so much.